Hi guys, in the previous video we did some analysis for the signal given, right, and we have managed to determine a0 over 2 and the value for an. Alright, for today in this video we're gonna continue solving this to find our bn and to write the final Fourier series expansion. Okay, so let's start. So here I have written the solution that we have obtained in the previous video, okay, tau over t0, and for an this is what we have, 2 tau over t0 sine and tau over t0. And from the previous video we managed to know that bn is actually equals to 2 over t0, and the integration has to be done for the period of select a selected period of time, okay, and the behavior of the signal and the sign multiply with the sign and the things that you found in the bracket. Alright, so next what we're going to do is we're going to substitute a value in it. Okay, so here, okay, let me enable this. Okay, here you're going to get the same thing, alright, and this is negative tau over 2 tau over 2, right, and we know this is 1, and this is sine 2 pi, okay, no change here, and not, okay, and this is t, right, no changes here. Right. Now you have to think of the way to integrate this. Okay, so what you can do, you can actually let the entire thing that you found in your bracket as u. Okay, u is actually equals to n t naught, this is t. So next you're gonna differentiate this in order for you to find your dt. Okay, this is similar step to what we have done in the previous video. Okay, so our dt now is equivalent to, okay, you have to bring this over, all right, this is 2 pi n, and you're gonna get du. Okay, so this is what you got, and you have to substitute in, okay, inside this equation. Okay, so if you substitute, this is sine u, okay, t naught 2 pi n du. Okay, same concept, this is a multiplier, hence you can bring it in front. Okay, okay, so this is sine u du. Okay, now you can solve this and also simplify whatever things that actually we can simplify, meaning we can cut this and 2, so we're gonna get something like pi n. Okay, and when we solve this we're gonna get negative cos u, okay, tau over 2 negative tau over 2. Okay, so bear in mind that when you want to substitute this value in, you have to substitute back your u, right, in the form of time. Okay, so let me just substitute back. So we're gonna get 2 pi n t naught, this is t. Okay, so this is tau over 2, this is tau over 2, and this is negative actually. So if you substitute in, this is cos 2 pi n t naught. Okay, so this one no issues. Here we have negative cos 2 pi n t naught. Okay, this is negative, okay, negative tau over t naught. I think I made a small mistake over here. I was supposed to add a negative over here, because this thing is by itself is a negative thing. You see, you have a negative, hence you're gonna have two negative. Okay, so negative. Okay, so this two is gonna be plus. Right, so instead of I'm gonna write twice, I'm gonna just make it as plus over here. So this one I'm gonna erase and I'm gonna replace it with plus symbol there. Alright, so this is plus, and here we have a negative inside. So note, okay, we when you have cos, okay, let's say x, you also can have cos which is negative x, so they are the same. Hence this thing can be also written as positive, the entire thing over here inside here. So meaning whatever that we have here and this one will be the same thing. So what I can do, I can just rewrite this for you. Okay, so I'm gonna rewrite, okay, 1 over pi n, okay, cos 2 pi n over t naught. Okay, and this is tau over 2. Right, then we have plus the same thing, yeah, cos 2 pi n over t naught. Okay, so here I'm gonna remove this negative, so I'm gonna have tau over t naught. Okay, close bracket. So you notice here this entire thing become similar. Okay, so hence we're gonna cancel off this. Okay, by cancelling meaning it's gonna be produce 0 over here, right? Hence the entire bn is gonna be 0. Right, so now we have managed to find a bn, right, an and a naught over 2. Right, so with this we actually can write the Fourier series expansion. So this is the Fourier series expansion, okay, by formula. Okay, this is trigonometric Fourier series expansion, and this is what we have obtained. Okay, and you notice here there is no bn. Okay, it's just an, and bn, the entire thing is become 0. So this is your final answer for the problem that I've just shown you. Okay, thank you guys.